These are the most popular supervised machine learning algorithms you need to know, from linear regression to neural networks. Start with linear regression, which predicts a number from your input features. Every dot is a film, and we're predicting a film's rating from its budget. Linear regression fits the line that minimizes the sum of the squared errors. Then, given a new budget, the line can predict the film's rating. Logistic regression is similar, but instead of a number, you predict yes or no. Will this film be a hit or a flop? It squashes that weighted sum through an S-curve, where the output is a probability. To pick the best curve, we measure how wrong its probabilities are on every film. That total is log loss, and we make it as small as possible. Next, k nearest neighbors doesn't fit a line at all. It just compares films directly. To judge a new film, it finds the k closest films. Each of those 5 neighbors carries a label, and then we take the majority vote. Similarly, to predict a number instead of a category, you just average those neighbors. Next, a support vector machine separates the data with a straight line. It chooses the line that leaves the widest margin on either side. The films sitting on that margin are the support vectors, and they alone hold the line in place. Next, a decision tree splits the data by asking a series of yes or no questions, checking every feature to pick the cleanest split. Then it repeats inside each half that is still mixed, so the boundary comes out as a staircase you can read off the tree. A random forest builds on this idea by growing hundreds of trees in parallel, each on a random sample of the data and a random subset of features. So each tree gives its own prediction, and averaging them reduces overfitting and cancels out their individual mistakes. Gradient boosting also combines many trees, but grows them one after another. We start by predicting the average rating, then the first tree predicts what that got wrong, and each new tree corrects the error that is still left. Add up hundreds of them, and the prediction bends into a staircase that follows the data. XGBoost adds 3 things to standard gradient boosting. First, regularization to reduce overfitting. Second, it handles missing values on its own. And third, it trains in parallel, which makes it fast. Finally, a neural network takes our features as inputs, passes them through hidden layers, and ends with a prediction. Every neuron does the same small job. Multiply the inputs by weights, add a bias, and apply an activation function. That output flows into every neuron in the next layer. This is what powers image and language models. So those are the 8 supervised models you need to know. They find patterns in the data and predict an answer. Follow for part 2, where we'll cover unsupervised models.